This is a session on calculation shortcuts and math tricks. A disclaimer to begin with, it's only the concepts that can get you a high score on the standardized examinations. These shortcuts and tricks are only for earning you that extra minute during the test and that extra point. This is not the main course of your preparation. So to begin with, a warm-up, we would be doing some inhuman calculations as we proceed. But to begin with, something simple, how to find square of a number ending with 5. For example, how to find square of 85. So the shortcut is that if the number is ending with a 5, its square would always end with a 25. And what comes earlier? If it's 8 here, multiply 8 by the next number, 9. 8 into 9 is 72. So 72 comes here. 85 square would be 72, 25. 35 square, so 25 comes here. It's 3, so 3 into 4, 12. 35 square is 12, 25. 95 square, so 9 into 10, 90, 25. 75 square, so 7 into 8, 56, 25. 125 square, so 12 into 13, 156, 25. You may want to pause the video and do it yourself. Something really big now, 245 square. Okay, so 25 comes at the end and 24 into 25 would be 600. Answer is 60025. You can flaunt it to your friends. How to solve these products? Now what's peculiar here is one, that the tens digits are the same and sum of the units digits is 10. This shortcut would work only in this case. 39 into 31. So the shortcut is the last two digits would be the product of the units digit here. It's 9 into 1. It's 9. But we need two digits here. So 9 would be written as 09. The same thing here, what comes before would be 3 into the number that comes next. So 3 into 4, 12. 39 into 31 is 1209. 72 into 78. 2 into 8 is 16. So 16 would be at the end. And 7 into 8, 56. 56 would come before it. The value is 5616. 83 into 87. 8 into 9 is 72. So 72 comes first. And 3 sevens are 21. So 21 comes at the end. 4 into 5, 20. And then 4 into 6, 24. Remember, 4 into 5, 20 comes here, and the last two digits, 4 into 6, 24. This decides the last two digits here. 85 square. So see, the concept can help you find out the squares of numbers ending with 5. 5 square, 25. It's like saying 85 into 85, 25. And 8 into 9, 72 comes here. The same thing. 65 into 65, the last two digits would be 25, 5 into 5, and 6 into 7, 42 comes here. The next shortcut, square of two-digit numbers. This shortcut will help you find squares of all two-digit numbers whatsoever. So 32 square, for example. Now, how this works is you have to imagine the number as, let's say, x, y whole square. And the result would be something like this. Imagine a box. The box has 3 compartments. X square comes here. Y square comes at the end. And 2xy comes in the middle. Remember, only one digit can come here and only one digit can come here. So let's do it now. Y is 2. So y square means 4 comes in this box. 2xy means 2 into 3 into 2, that is 12. So 12 comes in this box, but only one digit is allowed. So 2 comes here and there is 1 carry. And x square means 3 squared 9. 9 and plus 1 carry makes it 10. So 10 comes in the first box. The result is 1024. 32 square is 1024. Let's take 73 square. Let's do it quickly this time. 3 square is 9. 2xy means 7 to 3, 21. Double 42. So 2 comes here. 4 carry. 7 square 49 plus 4, 53. 73 square is 5329. 37 square, 9 comes here, 4 carry. 2 into 3 into 7, that's 42. 3 into 7 is 21, double 42. 42 plus 4 carry becomes 6. 4 carry. 3 square would be 9. And we had 4 carry here, so 9 plus 4, 13 comes here. 1369 is 37 square. Let's do it very quick now. 49 square, 81, 1, 8 carry. 4 into 9 into 2, 72 plus 8 carry, 0, 8 carry still. And 4 square is 16, 16 plus 8 carry becomes 24, 2401. 68 square, 4 comes here, 6 carry. 2 into 6 into 8 is 96, 96 plus 6 is 102. So 102, so 2 comes here and 10 carry. 66 square would be 36. 36 plus 10 carry would be 46. It's 4624. 63 square. 3 square is 9. No carry. 2 into 6 into 3 will be 36. 6, 3 carry. 6 square is 36. 36 plus 3 carry becomes 39. Answer is 3969. Let's move to the next concept. It's about multiplying 2-digit numbers. So let's take an example, 37 into 41. So how it works is, just remember this figure. Think of an I, think of an X, and think of an I again. Just remember this. And now you are multiplying 27 with 41. So first, see, it's I here. So multiply 7 and 1. You get 7. In the middle you have x, that means cross multiplication. 2 into 1 plus 7 into 4, that's 30. So it's 0 here and 3 carry, and then it's again I. So straight 2 into 4 is 8. 8 and 3 carry makes it 11. It's 1107. That's how you save some time. I'm sorry, I ended up finding 27 into 41. It's 37 into 41 here. Yeah, so don't commit those silly mistakes on the exam. It's 37 into 41 here. 7 into 1, see straight. So 7 comes here. Then cross multiply and add. 3 plus 28, 31. So 1 and 3 carry. 3 into 4, 12. 12 plus 3 carry it was. So it's 1517. Just to cross check, 37 into 40 would be 1480 plus 37, that's 1517. 43 into 52, let's do it again. 43 into 52. So 3 2s are 6 comes here. 8 plus 15, 23. 3, 2 carry, 20, and 2 carry, 22. 22, 36. 23 into 78. So you have 23, 78, 3 8 are 24, 4, 2 carry, 16 plus 21, 37, 2 carry, 9, 3 carry, 2 7s are 14 plus 3 carry makes it 17. It's 1794. 46 into 62, 6 into 2, 12, 1 carry, 8 plus 36, 44 and 1 carry makes it 5, 4 carry, 24 plus 4, 28, 28, it's 2852. 97 into 87, So 7 7s are 49. 9 you have 4 carry. 63 plus 56, that's 129. Rather, I'm sorry, it's 119. 119 and 4 carry makes it 123. So 3 comes here and you have 12 carry. 9 8 is 72. 72 plus 12 carry makes it 84. So the answer is 8439. 64 into 64. So of course this will help you in finding out the squares also. I've shared techniques for finding out squares otherwise as well. This is another way. 4 into 4 is 16. 6, 1 carry. It's 24 and then double of 24, 48. We had 1 carry, so 9. 4 carry. 6 6 are 36 and 4 carry makes it 40, 40, 4096. So this is another way of finding out squares for all the 2-digit numbers. The next shortcut is around multiplying the 3-digit numbers. So in this case, you have to remember this diagram: an I, an X, a star, an X again, and then an I again. Let's apply this concept. Let's say 137 into 412. 1, 3, 7, 4, 1, 2. So it's an I to begin with. 7 2s are 14. You have 4, 1 carry. Then it's cross. So cross multiply. 6 plus 7, 13 plus 1 carry makes it 14. You have 1 carry. Then you have star. So I'm sorry, I've drawn this star a bit wrong. The star needs to be this way. A vertical line and then an X around it, something like this. Okay. So now let's apply. The third position is going to be 1 into 2 plus 7 into 4 plus 3 into 1. So see, this is what this means. Two extreme numbers have to be multiplied, added, and then this also has to be multiplied and added. So 1 into 2 is 2 plus 4 into 7, 28. That's 30 and 3 more. That's 33 plus 1 carry. That is 4. So you have 3 carry here. Then cross means these two. 1 plus 12, 13 plus 3 carry. That is 6. You have 1 carry here. And then finally 1 into 4, 4 plus 1 carry. That becomes 5. So the product is 56444. 431 into 352. 431, 352. So let's do it a bit quickly this time. 1 into 2 is 2, no carry. 6 plus 5, 11, 1 and 1 carry. Then 8 plus 3, 11 plus 15, 26 plus 1. That means 7. And then you have 2 carry. Then 20 plus 9 and the 2 carry that we had, that makes it 31, 1 and 3 carry. 4th is a 12 and we had 3 carry here, so 4th is a 12 plus 3 makes it 15. It's going to be 151712. 234 into 278. I'll just do this one and leave the rest for you. 4 8 are 32, 2, 3 carry, 24 plus 28, 52 plus 3, 55, 5 carry, and then 16 plus 8, 24 plus 21, 45 plus 5, 50, so 0 and 5 carry. 14 plus 6, 20 plus 5, 25. 2 carry, 2 2s are 4 plus 2 carry it was, makes it 6. You can try these. Just pause the video and solve it yourself. The answer for this one is 75006. For this one, it is, here it is 664164. The next one. Okay, this is interesting. So this can be solved by 364 and assume a 0 here. It's 078. So this is how this way will help you solve such multiplications also, where one number has 3 and the other has only 2 digits. 4 8s are 32. 2, you have 3 carry. 6 8s are 48 plus 28, that's 76, plus 3 79, you have 7 carry. Then 3 8s are 24 plus 0 24 plus 42, that is 66, plus you had 8 carry, so that's 4 7 carry. Then this is 21 plus 0, 21 plus 7 28, so you have 2 carry. And finally 0 comes here, so you have 2 coming here. The next concept, multiplying two nearby numbers. This is my favorite. So if you have to multiply, let's say a 107 and a 108, we need to take a base. Think of a helpful base such as 100 here. 100 becomes my base, okay, and draw a dotted vertical line. On the right of the line, the number of digits would be the same as the number of zeros in my base. Okay, so 100 is my base. On the right, you have 2 digits coming. Okay, so now take the difference between each number and the base. It's 107, so 7, and 108, the difference is 8 again. So 7 into 8 comes on the right, and here choose any of these two numbers. On the left, choose 107, let's say, and from the other number subtract the base. 108 minus 100, that's 8. Add these two numbers. If I had taken 108 here, it would have been 108 plus 107 minus 100, you get 7. You'll always get the same answer. Okay, so on the right side I have 56, on the left side I have 115. That means the value of this product is 11556. Let's do it quickly this time. The base is 100 again. On the right side it would be 9 and 4. On the right side it would be 36. On the left side it would be 109 plus 4, 113. The value is 11336. 112 into 109, it would be 12 into 9, 108. But remember, I can have only 2 digits here, 08. So 1 carry comes here. 112 plus 9 is 121, and 1 carry makes it 12208. 14 into 18, now in this case the base is going to be 10. And therefore on the right side I can have only 1 digit. 4 into 8 is 32, that means 2 comes here and 3 comes here as carry. And 14 plus 8 or 18 plus 4 is 22, plus 3 carry becomes 25. That means 14 into 18 is 252 very quickly. 106 square is 36 coming here. So see, this method can be used for finding out the squares very quickly. That means 106 into 106. On the right side comes 6 into 6, 36. On the left side it would be 106 plus 6, 11236. So see, 106 square is 11236. 18 square, you would have 8 square, 64 here. So 4 comes here, only 1 digit can come here because the base is 10. 6 comes here, and on the right side it would be 18 plus 8, 26. 26 plus 6 carry becomes 32. So 18 square is 324. 103 into 109. Let's start doing it mentally. 103 plus 9, 112, and 3 into 9, 27. The value is 11227. 102 into 103, it would be 10506. 108 square, 11664. How am I doing so quickly? 8 square, 64 comes here. 108 plus 8, 116 comes here. 19 into 17. On the right side, it would be 9 into 7, 63. 3, 6 carry. 19 plus 7 is 26. 26 plus 6 carry is 32. So it's 323. 17 square. 17 square means 7 square, 9 comes here. You must remember ideally until 30, I would say that people preparing for competitive exams should remember these values. Anyway, 7 square is 9, so 4 carry. 17 plus 7, 24 plus 4 carry becomes 28. So 17 square is 289. 119 square, try doing it in your head. 19 square would be 361, so 61 comes at the end, and 119 plus 19 would be 138. 138, the carry was 3, becomes 141, at the end was 61. So you have 14161 as 14161. It's easier to do it than to write sometimes. 119 square, 138, and then 361. So 361, 138 becomes 141 out of 3 carry, and 61 comes at the end. Let's try one more. If it's something like 106 square, very quickly, 11236 can be very, very fast. Now what if that first number here is not 1? It's not, the base is not 100 or 10, the base is 200 in this case. So there's a slight difference here. The same, everything remains the same. I would say 203 plus 7 coming here. On the right side I have 3 into 7. The only difference is that if the base is 200 and not 100, I need to multiply this part by 2. If the base were 300, I would have multiplied by 3. So 203 plus 7 is 210, into 2 is 420. 42021 is the value of this product. Let's try this one. 308 plus 4 is 312, into 3 this time would be 936 coming here, and 8 4s are 32 here. That's the value. 401 square, so 401 plus 1 is 402. Multiply 402 with 4, it would be 1608, and 1 square is 1, but we need 2 digits here, so it becomes 01. 401 square is 160801. 33 square, 33 plus 3 would be 36. 36 into 3 would be 108. On the right side, on the left side, I'm sorry, the right side 3 square is 9. So 33 square is 1089. 28 square, on the right side it would be 64, so 4 and 6 carry. On the left side it is 28 plus 8, 36, into 2, 72. 72 plus 6 carry makes it 78. The value is 784. 708 square. Try doing it in your head. Try pausing this video and try doing it in your head. 708 plus 8 is 716. Now 716 into 7. So see, mental calculations are a lot about dividing your mind into two parts. One part of your mind must remember what you have calculated, and the other part must calculate. So 70 plus 8 is 716. 716 into 7. So let's multiply 700 by 7. That's 4900. Remember 4900? And then 16 into 7 is 112. 4900 plus 112. That means 5012. And on the right side, you have 64. So 5012 and 64. So the value of 708 square would be 501264. This is more out of interest. You practically, if you get such a number on your test, you may just use a method that is in your reflexes. You need not apply these shortcuts all the time. Up to you. Okay, the other case where the numbers are not more than the base, they are a bit less than the base. So 97 into 98. If I take 90 as base, I would have to multiply by 9, which would be cumbersome. So I take the base as 100. However, now see, the numbers would be negative. 97 is one number, the other number is smaller. 98 minus 100 would give me minus 2, not plus 2. So this comes here. On the right side, it would be minus 2 into minus 3. Okay, so it becomes 95. Two zeros here, so two numbers need to come on the right side. It's 9506. 194 into 199, it's 194 minus 1, it's 193. And I need to multiply this by 2 because of course I'm taking the base as 200. On the right side it would be minus 6 into minus 1. So 2 into 193. How do we do this quickly? So see, I know 193 is 7 less than 200. So its double would be 14 less than 400. 14 less than 400 would be 386. That's on the left side. And on the right side we have 6. So we write it as 06 because we have two zeros here. 299 square. So let's try doing it mentally. 299 minus 1 is 298 into 3 would mean 894. How I did it quickly is 298 is 2 less than 300. So its triple would be 6 less than 900. So that's 894. I get 89401 as the value of 299 square. 39 square, so 39 means 40 base, 39 minus 1 is 38 into 4. How to multiply quickly by 4? Double it twice. So 38 into 4, double of 38 is 76, double of 76 is 152. 152 comes on the left side. On the right side I have minus 1 square, which is 1. So the value of 39 square would be 1521. 29 into 28. So my base is 30. 29 minus 2 would be 27. 27 into 3 would be 81. 81 is what comes on the left. On the right I have minus 1 into minus 2, which is 2. So the value of 29 into 28 is going to be 812. 498 square, try doing it quickly. 498 minus 2, 496 into 5 would be 2480. How I did it quickly is 496 is 4 less than 500. So its 5 times would be 20 less than 2500. So that's 2480, and then minus 2 square is 04. So 498 square is 248004. And now this is a complicated one. I will explain how to handle these where one number is below the base, the other is above the base. So the base is 100. We can do 99 plus 3, or we can do 103 minus 1. For the left side it remains 102 either way. On the right side you have minus 1 into positive 3. So on the right side you have 102. I'm sorry, one side you have 102, on the right side you have minus 3. So it's 10200 minus 3 turns out to be 10197. So the value of this is 102 and then 00 because the base is 100, it has two zeros here. So it's 10200 minus 3 turns out to be this much. Look at this one. 194 plus 4 is 198 into 2 would be 396. So 194 plus 4 base is 200, so into 2. The right side I have minus 6 into positive 4. 198 into 2 is 396. And then I have minus 24 here, so it would be 39576. 39600 minus 24. 29 into 32, so 3 into 29 plus 2, that is 31. And then you have minus 1 into positive 2 minus 2 here, that is 930 minus 2, that would be 928. 48 into 53, so 50 base. 48 plus 3 is 51. 51 into 5 would be 255. On the right side you have minus 2 into positive 3, that is minus 6. So 2550 minus 6, that is 2544. 498 into 506, the sum would be 504. 504 into 5 would be 2520. On the right side you have minus 12, so 2520 minus 12, that means 25200 minus 12, 25188. That's the value. Now to find out the square of numbers around 50. Slightly different approach here. Always take the base as 25. I'm sorry, the first two digits as 25. The base would remain 50 only, because we are talking about, of course, the numbers around 50. Example is 54 square. So the base would be 50 and the difference gets added to 25. It's 54. It's 4 more than 50. So we have a plus 4 with 25. And on the right side, we have the difference is 4. So we have 4 square on the right side. Answer would be very quickly 2916. The shortcut is 25 plus the difference and then difference square. On the right side of the line, we have two digits coming in. For example, if we had 53 square, it would have 25 plus 3, 28 on the left side and 3 square 9 on the right side. But we need two digits, so we would put a 0 in between. It would be 2809, 53 square. 57 square, 25 plus 7, 32 on the left side. On the right side, you have 7 square, 49. The value would be 3249. 48 square, now this is minus 2. So you have 25 minus 2 on the left side, and you have minus 2 square on the right side. It's 2304. Let's try doing it mentally now. 43 square, so 25 minus 7, 18 on the left side, minus 7 square, 49 on the right side, so it's 1849. 38 square, 25 minus 12, 13, and on the right side you have 12 square, 144, so 13 and 144 becomes 1444. 25 minus 12, 13 you had here, minus 12 square you had 144 here. 1 comes this side, the result is 1444. 63 square, 25 plus 13 is 38. 13 square is 169, so 38 and 1 carry becomes 39. The result is 3969. 38 here, 169 here. The result is 3969. And practically, the easier ones, 2601, 54 square, 2916, 56 square, 3136, 58 square, 3364. I can practically actually calculate faster than I can talk or write. So this can be very quick. 49 square, 2401, 41 square, 1681, 42 square, 1764. So this can be quite helpful, I would say. Square of two-digit numbers ending with 1. So for numbers such as this, 71 square. So if there's a number you have to find the square for, and you need the square of the previous number. I know the square of 70 square is 4900. To this I can add the number I know the square of and the number I need to find the square of. This will all add up to the square of the number I am looking for. Okay, for example, if it is 61 square, 60 square is 3600. Add 60, add 61. 3721. If it is 31 square, I know 30 square is 900. To this I add 30, I add 31, I get 961. So 81 square, 6400 is 80 square, so add 80, 6480, add 81, 6561. The answer is 6561 here. 31 square, I just did it, 961. 91 square, I know 90 square is 8100, add 90, 8190 plus 91, 8281. 61 square, 3600 plus 60 plus 61, 3721. Oh, I just did it here. 51 square, 2500 plus 50 plus 51, 2601. So this can be helpful even in bigger numbers, in case sometimes you know 121 square. 120 square is 14400. To this add 120 and 121, effectively 241. I know the result is going to be 14641. So similarly, if I need to find 131 square, it's 16900 plus 130 plus 131, that's 261. It's going to be 17161. All right, the next concept is these numbers, 78 into 82. What's peculiar about this one? 78 into 82. What's peculiar in my opinion is that what lies in between these numbers, exactly between the average of 78 and 82, is 80. So I can write 78 into 82 as 80 square minus 2 square, the common difference. See, the average is 80, the common difference is 2. I can write this as 80 square minus 2 square. 6400 minus 4 is 6396. 43 into 37, that's 40 square minus 3 square, that's 1591. 29 to 31, that's 30 square minus 1 square, 899. Let's start doing it in our head. The moment I said head, we have a big number. Okay, never fear these big numbers. 200 square would be 4 and then 4 zeros, 40,000 minus 1. 40,000 minus 1 would be 39,999. That's 40 square minus 4 square, 1600 minus 16, that's 1584. That's 70 square, 4900 minus 16, that's 4884. And this may work in other cases also. 24 into 26, 25 is in the middle. I know 25 square is 625, so 625 minus 1 square, the answer would be 624 here. This can be written as 25 square minus 1 square, 624. This can be written as 35 square minus 2 square, that's 1225 minus 4, 1221. This is 15 square minus 3 square, that is 225 minus 9, 216. This is 18 square minus 1 square, that's 324 minus 1, 323. This is 75 square minus 4 square, that is 56. 25 minus 16, that's 15. Sometimes I miss it. 75 square is 5625 minus 4 square, that's 16. 5625 minus 16 is 5609. 95 square minus 3 square, that's 9025 minus 9, that's 9016. Next, fast multiplication was single digits. So in case whatever shortcuts I told earlier, they don't come naturally to you and you have to go the conventional way of multiplying. I'm sorry, this is a different concept. It's about actually multiplying with single digits, small numbers. So multiplying by 2, I would say just double it. So 72 into 2, 144. If it doesn't come naturally to you, break it up. 70 into 2 it would be 140, and then 2 into 2 is 4. 140 plus 4 would be 144. 37 into 4. So multiplying by 4 would mean doubling it up twice. 37 into 2 is 74. 74 into 2 is 148. Multiplying by 8 would mean doubling it up thrice. 42 double 84, double 168, double 336. And every time you can just keep dividing it up. You know, always another shortcut around the corner. This could have been done by 40 into 8, 320 plus 2 into 8, 16. 320 plus 16 is 336. You know, but depends on the number. Very often, intuitively, what comes to me is if I have to multiply a number by 8, I just double it 3 times. So if it is, let's say, anything 27 into 8, I would say 27, 54, 108, 216. The value is 216. That's 27 into 8. 46 into 5. Okay, so multiplying by 5 basically means dividing by 2 and then multiplying by 10. So that's 23 into 10. The value would be 230. Multiplying by 3. The easiest way in my mind is to always just break it up, because multiplying by 3 is going to be easy. So make it 80 into 3, 240 plus 3 into 3, 9, 249. So think of any big number. See, both the numbers are big here, but when you multiply it by 3, because 3 is a small number, multiplication are going to be easy. 70 into 3 is going to be 210, and then 8 into 3 is going to be 24. So it's 210 plus 24, it's going to be 234. You know, multiplying with, okay, one more, 74 into 3. So 70 into 3 would be 210 plus 12, that's 222. When you have to multiply by 6, so I would say that first multiply by 3 and then double it. So 77 into 3 would mean 231. Again, 70 into 3 is 210 plus 21, 231, and then double it. 231 into 2, 462. Multiplying by 7, I would say there isn't actually a shortcut, so you'll have to look at other ways. Again, just try breaking it up. 40 into 7 plus 2 into 7, so 294. If both the numbers are big, 78 into 7, then there isn't practically a shortcut. You know, 70 into 7 is 490 plus 56, 546 would be the value. So probably you will take as much time if you were to actually multiply also. So depends on your intuitive skills. But yeah, if practically I have to do it, I would always just multiply, take the units digit out. If it is 93 into 7 that I have to do, I would do 90 into 7, 630 plus 3 into 7, 21. 630 plus 21 is 651. If you have to multiply by 9, I always suggest that you multiply by 10 and then subtract. So 46 into 9, I would say 46 into 10 is 460. 460 minus 46. Subtracting is always a bit more difficult than adding. So I would always look for some shortcut. 46 into 10 is 460. So if I have to subtract 46, I would first subtract 50 and then add 4. So 460 minus 50 is 410 plus 4, 414. That would be the value of 46 into 9. Take another example. If I have to do a 73 into 9, that's really difficult relatively. So again, in this case, I would probably go 70 into 9 and then add 3 into 9. So that makes it easy. If I had, suppose, 89 into 9, so I know the way out always, this way you always have an addition root, you know. So 80 into 9 would be 720 and then 9 into 9 is 81. So 801 it turns out. 89 into 9 is another way, but as I said, 890 minus 89 is relatively a bit more complex, although of course you will get to an 801 only. Multiplying by 11 is relatively much easier, and I would say smarter. 57 into 11. So always multiply by 10 and then add once. So 570 plus 57, 627. So 11 is easy to multiply with. If you had something like 89 into 11, so 890 plus 11 is 979. Oh, I remember a shortcut for this. Something that I don't personally use, but yes, if you have something like if you have a number being multiplied by 11, you would always have these digits would repeat as the first digit and the last digit, and in the middle you will have the sum of these digits. So 473. If it is 62 into 11, it would turn out to be 6 and 2. In the middle you would have 6 plus 2, 8, 682. Sometimes there would be the case of a carry. For example, let's say 76 into 11. So you have a 7 here, you have a 6 here, but 7 plus 6 becomes 13. So 3 comes here and 1 comes here, as carry, so it becomes 836. So that's another way of multiplying by 11. Multiplying by these numbers which are powers of 5. So this I have already covered. You have to multiply a number by 5, multiply by 10 or add a 0, and then divide by 2, so then it becomes easy. Again, while you are doing it, actually dividing, so suppose you're not able to do it intuitively, practically you can do 900 upon 2 is 450, and then another 25, that's 475. In case it is not coming intuitively to you, on your exam, don't spend time in drawing this entire thing. You can just do it directly here. 950 means it goes 4 times. You can do it mentally. This much can be done mentally by everybody. 1 remains. 15, that means 7. 14, 1 remains. And then 10, that means 5. So never waste your time on actually drawing this. Always do it directly right where you have the fraction written up for you. 78 into 25, so 25 means add double 0 and then divide by 4. Okay, so 5 square means add 2 zeros, divide by 2 square, 4. Again, do it intuitively. You have 78, so 1, 3 remains, 38, 9, 36, 2 remains, 20, that means 5, and then 0 comes, it's 1950. So that would be the value of 78 into 25. So more than the multiplication, is the division skill that I'm explaining here is a lot more useful. 424 into 125. So 125 means add 3 zeros and then divide by 8. Once again, don't worry about drawing it. 42 means 5 comes here, 2 carry. 24 means 3 comes here, and then you have 3 zeros following it. So short and easy, it's 53,000. 625 would mean you rarely see such big numbers on the test. However, for the sake of conceptual clarity, let's do this one also. Quite easy. This would go once, 8 carry, 88. So this would go 5 times. 8 remains, so not carry, I'm sorry, remainder. 88, 8 remains, 80, so 5, and then these 3 zeros just come as they are. The value would be 155,000. One more, 488 into 125, so very quickly, 488,000, 5 cube is 125. Divide by 8. 48 goes 6 times, and then 8 would go once, so this is 6, 1, and then 3 zeros come the way they are. So that's 488 into 125. Next concept, conventional multiplication done fast. So if none of the shortcuts that I've suggested really come into your intuitive ways of multiplying, I suggest that you continue using your conventional way of multiplying, the same way that you've been doing since childhood. However, I suggest that don't do it digit by digit. You can do it directly, 3 into 35, you can directly write a 105 here. And then 2 into 35, that's 70. And then it is 805. I would practically never actually multiply digit by digit, So, and yeah, if you're good with numbers, you can do 35 into 2700 plus 35 into 3, 105, that's 805. Those shortcuts always may click, but yes, if you are to actually multiply conventionally, please try doing it both the digits in one go. 78 into 25, let's try doing it as well. 5 into 78, that's 390, and then 2 into 78, that's 156. So you have 0, 5, 1 carry, 8, 9, 1, 9, 5, 0. 42 into 26, 6 into 42 would be 252, comes here. 2 into 42 would be 84. So it turns out 1092. That would be the value. 248 into 231. So sometimes you can in fact do 3-digit numbers directly. 248 into I would be falling short of space there, sorry. 248 into 231. So you have 248 coming here first, then you have 3 into 248. That may not be very straightforward for most of us. That's 744. 2 into 248, that is 496. So you have 8, 1 carry 17, 57288. Yeah, it will take some time because yeah, such a number would take time any which way unless you are a human computer. 48 into 124, 88 into 125. So again, you can do it this way, or again, as I suggested, that it's 125, so 488, you can add 3 zeros and divide this by 8. So it turns out this is 61,000. Sometimes you can end up saving a lot of time. Conventional division done fast. So if you have to actually divide, as I suggested, don't waste your time in writing it this way, 3, 5, 1, 2. This is not needed. You can just do it directly here. So see, do it mentally. Everybody can do this mentally. 32, 8 fours are 32, so 4 comes here. 3 remains, 31. That means I can have 3 here. 31, 24 goes, 7 remains, 7 and 2, 72. This would go 9 times. So the value is 439. So try this. 9, so this would go 8 times, 72. 6 remains, 66 would go 7 times. 3 remains, 36 would go 4 times. Nothing remains. Try this. 17 would go 1, 6 remains, 11 would go, sorry, 6 remains, 61 would mean 5 times, 6 remains, and 62 would go 5 times, 7 remains, so that means a decimal is going to come, and that's where I suggest that you should know these small divisions. 1 upon 11 is 0.09. So if 7 remained here, it's going to be 0.0909 into 7. That's going to be 0.636363, 0.63 bar. So yes, another thing I would want to insist is that you should know these small numbers. 1 upon 2 is 0.5, 1 upon 3 is 0.33, 1 upon 4 is 0.25, 1 upon 5 is 0.2. So you would know if 1 upon 5 is 0.2, 1 upon 2 upon 5 is going to be 0.4, 3 upon 5 is going to be 0.6, like that. 1 upon 6 is 0.1666. Therefore, 2 upon 6 is going to be 0.3333, 3 upon 6 is half, 4 upon 6 is 0.66. Likewise, 1 upon 7 is 0.142,857. That's not important. You can just remember at least 0.14. 1 upon 8 is 0.125. So this is important. So you would know 3 upon 8 is going to be therefore 3 times 0.375. 1 upon 9 is very important, 0.1111, and therefore 7 upon 9 is going to be 0.7777. So this is important, I would say. We all must know 1 upon 10 is 0.1, of course, and 1 upon 11, as I just suggested, is 0.090909. So some more. So do it directly. 24 would go 3 times, 3 remains, 38. 5 times, 3 again remains. 39 would go 5 times. So you have 4 remaining. 1 upon 7 is 0.14. So 4 times would make it 0.56, 0.57, something like that. So that is the value. Upon 8, so this would go 6 times. Nothing remains. 8 would go once. 2 won't go, so 0 comes here, and then 2 upon 8 means 1 upon 4, that's 0.25. So that is the value of this expression here. Alright, so the next one is finding HCF and LCM very quickly. So 60 and 40, we were taught in childhood to do something like this: 60, 40, 100, and then divide this by 2 first, and you get 30, 20, 50. No, my friend, you don't have so much time on your standardized examination. You have to be smart. So I will tell you two ways, one which will work for everybody, one which may work for only those who are really good with numbers. I would say, first of all, break it up as much as you can. Just break it into prime bases. So 60 would have 2, 3, and 5. 40 would have 2 and 5, nothing else. 100 would also have only 2s and 5s. This would have 1, 3, 2 2s, 1 5s, 3 2s, 1 5, 2 2s, 2 5s. So this is what the breakup means. For finding out the highest common factor, you just have to see what is the power that is common everywhere. So the highest power of 2 that is common everywhere is 2. So HCF would have 2 raised to power 2. Highest power of 3 that is common everywhere, no, there's no 3 here. So there would be no 3 involved here. Highest power of 5 common everywhere is 1. So HCF is going to be 4 into 5, 20. Coming to LCM, I just need to select the highest powers for each prime base. So highest power of 2 here is 3, highest power of 3 here is 1, highest power of 5 here is 2. So 8 into 9, 8 into 3, 24, 24 into 25 is 600. The LCM is 600 for this expression, the HCF is 20. Another way I would suggest, which may not work for everybody, is this one. See, use it if it only applies intuitively to you. Take the highest number, 100, and look at the next number and see what new does it bring. What does 40 have that 100 doesn't? 40 has 3 2's in it, 100 has only 1 2. So to include 40 also, I need to multiply 100 by 2, it becomes 200. And then what does 60 bring that is not already there in 200? 60 brings an additional 3. 200 does not have a 3 as a factor in it. So 200 needs to be multiplied by 3. The LCM is 600. So that is the fast way of calculating LCM. Personally, I always do it like this. So this similarly here, I would look at 500. I would say what new does 16 bring in? 500 has only 2 5's in it. I'm sorry, two 2's in it, while 16 has 4 2's in it, and therefore I need to multiply this by 2 square 4 to include this. 500 into 4 would make it 2000. So now 120, what new does it have? That 2000 doesn't, it has a 3 in it. So now the LCM is going to be 2000 into 3, 6000. Coming to highest common factor, I would just very intuitively see that C16, in this case, start with the smallest number. 16 has only 2's in it. It has 4 2's, this has 2 2's, this has 3 2's. So the HCF is going to be the smallest number of 2's, which is 2 2's. The HCF is 4 here. LCM 6000, highest common factor or greatest common divisor 4. The next concept, and this is my real favorite, something that in my days when I was taking my exams used to help me a lot in solving the questions, approximation techniques. So let's begin. So in most questions requiring hefty calculations, the answer choices are generally widespread. Smart test takers need not spend significant time in reaching the exact answer. What they can do is they can just quickly find an approximate value and use the answer choices to their benefit, and in the process end up saving a lot of time. Approximately 20% of the questions in the math section of these aptitude examinations can be solved using approximation. So let's take an example here. So this is a high difficulty level question, I would say. You have to find the value of this, and these are the answer choices. So something that works very well in these cases, these questions, is that you just consider the first few numbers. The later ones would just have insignificant values. So you have square root of the first number, square root of 6 would be approximately 2.4, 2.5 something. So write it as 2.4 plus square root of, so 6 plus 2.4 is the square root of 8.4. So square root of 8.4 would be roughly 2.8 something, 2.8, 2.9. So take it as roughly 3 something. Square root of 2.4 plus 3. Have faith, the later values are going to get much smaller. They won't actually have a practical impact. So square root of 2.4 plus 3, square root of that, square root of 5.4. And this is the part I'm talking about from here. You know, I took 2.4 for this one and rest of it all just adding up to roughly 3. So you have this value as, say, square root of 6 plus square root 5.4 turns out to be roughly, this is roughly 2.8 or something, 2.7, 2.8. So this is only going to be around square root of something like to 8.8 or something, and then just see what it turns out to be, 2.8, 2.9, and look at the nearest number. The answer is going to be 3. See, I took the first few values and the values turned out to be just close to 2.9. The later values are going to be insignificant. So this is something that works in a lot of these questions. Very often you have questions such as these: 1 plus 1 upon 2 plus 1 upon 4 plus 1 upon 8 plus 1 upon 16. Just add up the first 4 or 5 values, take out approximate answer. For example, this one, this is 0.5, this is 0.25, 0.125, 0.0625. So this is 0.2 roughly, 0.45, 0.95 plus 1. So you have approximately 2. So look at the answer choices, and whichever answer choice is closest to 2 would be the right answer choice. So this works out very well in a lot of questions. Now let's find out the ways of actually calculating through approximation. So suppose you're solving a question, eventually you have to find out the square root value of something like, let's say, 42. You actually have to find the value. How do you do this? So before we get to this one, let's take an inhuman number. You know, if it is something as big as this one, what do we do? Of course, this won't appear on the test, but if you can solve this, you can of course solve the easier ones. So how you do it is, first of all, just count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I would always count an even number of integers, so this roughly turns out to be square root 29.7 into 10 raised to power 32. Again, the same thing, the later numbers won't have any significant value in the bigger scheme of things. So 10 raised to power 32, when it comes out, it becomes 10 raised to power 16. And then practically I just have to find out the value of 29.7 square root. And see how I do it quickly is, see, 5 square is 25 and 6 square is 36. Okay, so 29.7 is of course going to lie between these two. So the difference here is 11. The difference is 11. For this entire one integer, the difference is 11 in square, and the difference between 25 and 29.7 is 4.7. 4.7 is the distance that we need to travel, and 11, if we traveled all 11 units, the value would have been 6. So 4.7 upon 11 is approximately 0.43 something. Okay, so my answer is going to be 5.43. The answer to this technique always comes out to be a bit less. So practically the answer would be just a bit higher than this. Practically the answer should be something like 5.4445, something like that. Trust me, this is good enough. Even if you said 5.4, this would have been good enough. You don't have to come to the second place of decimal at all. Just an approximation is good enough. So the value for this big thing turns out to be 5.4 into 10 raised to power 16. I took some time out and actually did it by calculator. The real answer is 5.453 into 10 raised to power 16. So see, what we have here is something very, very close. And as I said, what you get here is just a bit less than the actual value, because when I'm doing this, I'm assuming it to be a linear curve, while it is not a linear curve. It is an exponential curve. It's a square curve. So my answer would always turn out to be a bit lower than what the actual value is. So again, don't worry about this higher maths. Just take care of this. So similarly, square root 42 now had to be found out. So something like square root 42 is practical. You will find such values on your actual exam sometimes. So I know 6 square is 36, 7 square is 49. If I had traveled all 13 places, the answer would have been 7, but I don't have 7 places to travel. I only have 42 minus 36. I have only 6 places to travel. Turns out to be 0.46, and therefore I would say my answer would be just a bit more than this. My answer should be something like 6.48 or something. Let me just pause the video and use my calculator. So you won't believe the actual value in front of me is 6.4807 something. So we could get to the right value to the second place of decimal. Works very well, this method. You won't find it in any books anywhere. It's something that I came up with as a teenager. Numbers were one of my best friends, and I would just keep coming up with these techniques. Anyway, let's take something more practical. 4534. So first of all, take 10 square out. So you have 10 square out means 10 comes out of the square root. 10 into square root 45.34. This is very close to the example we just took. So 36, 49, base becomes 13, and I have to travel only 9.34. 9.34 out of 13 is 0.72 something. So my actual value should be just a bit more than 0.72, should be 0.74, 0.75, something like that. And 6.7475, because of course this is 6, it's between 6 square and 7 square, should be somewhere around this value. The actual value here is, of course, and I took 10 here, so yeah, 10 into 6.74, I said 67.4, the value is 67.33. So works out very well. Very smart way of finding out the square roots. Look at this one. So 2 and 2 go 7. So 100 into square root 7.59, or let's call it 7.6. It's going to lie between 4 and 9. The difference is 5 here. It's going to lie between, of course, 2 and 3. So 2.4 and 9.5, but I can travel only 3.6 places. So this is exactly 0.72, 2.72. So my actual answer should be just a bit more, something like 2.74, 2.75, something like that. In 200 to something like 274 or something, so yeah, 275.53, quite close to where we were. Square root 240. So how do we do this? So 240 has a 16 and a 15 in it. I can take 16 out and it becomes 4 outside the radical sign, root 15. And square root 15 is just a bit less than 16. I know 40 square is 1600. I know 39 square is 1521. So this should be just a bit less than 3.9, something like 3.8 or something, you know. So in this case, I would know 3.8 square and 3.9 square. 3.9 square is 1521. So 14.44. I would just roughly see this is approximately 0.8 and the difference is 0.6. So 3 out of 4 is a fraction. So I would say this is something like 3.875 or 3.88. So actually I'm cutting it just too fine. 4 into 3.9 also would have been okay, but I'm saying it 4 into 3.88. So it's 7.76 into 2, 15.52. So something like 15.5 or so is the value I should be reaching out to. So something like this, yeah. So 15.49. Yeah, you'll of course. So you're reaching the approximate values, and have faith the answer choices on such complex calculations wherever they are always well spread. Okay, so simply you can pause the video and do it yourself. I know 5 square is 25, 6 square is 36. The difference here is 11. The difference here is 6. 6 upon 11 is 0.54. So it should be 5.54, just a bit higher than this, something like 5.56, 5.57. 5.57 it is. Let's do it very quickly. Square root 92 turns out between 81 and 100. The difference is 19 here. The difference here between 81 and 92 is 11. 11 upon 19, roughly 0.6. Very quickly, should be something like 9.6, you know, 9.592. So practically this is how I would do it in like 10 seconds and actually save a lot of time. Approximation for multiplications. Let's take some inhuman expression just because I want to show that it is quite easy to do. So put a decimal after one place and just count 2, 4, 6, 8, 10, 12, 13, 15, 16, 17, 18, 20, 22, 24, 26. Okay, so into 10 raised to power 26. So we have 2.26. Let's round it off to 2.3. I rounded off one on the higher side. I will round off other on the lower side to just have some sort of a balancing thing. 2.3 into 8.2 into 10 raised to power 26. I can actually solve it, or I can go for approximation again. I would say, now see, this is something very interesting here. I would want to convert this bigger number into something more comfortable to work with. So I would say 8.2. I want to make it a 9 for it to be easy for me to handle. 9 means an approximate 10% increase. Okay, so if I'm increasing one number by 10%, I would want to decrease the other number by approximately 10%. So decreasing by 10% would mean 2.07 something. For saving time, I simply take it as 2. Works out fine, you know. I know that I have reduced it more than I should have, so whatever I'm getting is going to be a bit less than the actual value. So if it's 18 into 10 raised to power 26, my answer should have been a bit higher than this, something like 19 into 10 raised to power 26 or something like that, you know. So yeah, see, practically the answer is just a bit more than 18 into 10 raised to power 26. So very quickly, how you do it is just remove, first of all, make the numbers smaller and take everything else in the form of power. So if I had 374 into 792, I would say 3.7 into 7.9 into 10 raised to power 4. Okay, and then I would go about solving it, and then reduce one term, increase the other term, and rather than doing it absolutely, so if I had done it this way, that if I say I will reduce each by absolute number, if I said this is 2.0, so I increase it by 0.3, I say make it 8.5, I would get a relatively an answer that would not be as close. Even then I would not get a very bad answer 2 into 8.5 turns out to be 17. Still, it's not a very bad answer if I'm reducing by absolute quantities. Still, I'm getting a reasonably good answer. But if I do it percentage wise, I get an answer which is almost accurate. So take one more, 337 into 72. I would say make it 3.37 into 7.2 into 10 raised to power 3 and then play around. Okay. So 10 raised to power 3 means 1000, these many thousands. I'm decreasing by this by 10%, so I'm increasing this by 10%. 3.3 becomes 3, 7.2 becomes 8, 3 into 8, so that's roughly 24,000. See, otherwise this would have taken me so long, but I know in a matter of few seconds it's 24,000. And the last digit, another thing, see if you have really close answer choices, you know that last digit is going to be 7 into 2, 4. So something close to 24,000 and ending with a 4. Actual answer is 24,264, very, very close to where we were through approximation. Take another one, 43 into 73. So see, very quickly I have made this a 50 increase of 15%. So decrease this by 15%, roughly decrease it by 10 or 11. 62, that's approximately 3100. And the real answer is quite close, 3066. 64 into 91. So I've increased this by 10%. So decrease this by 10%, 57, 58 something. Slight mistake here. This should have been 57.5 rather. So you should get 5750, 5824. So yeah, you end up getting close enough to these approximation ways. And now similarly, approximation for division, very similar approach. Take some inhuman number for just to explain the concept. I say 97.22 here and 23.64 here, 10 raised to power 4 and 479. So 10 raised to power 9 here, 10 raised to power 4 here. So I'll get something like 10 raised to power 5 here, 9 minus 4. And then I have 97 upon 23.64, rounding it off on the higher side. Or let's keep it at 23.64. I just want to make it 100, so I will increase it by 3%. So 100, 23.64 plus 3% would be approximately 0.6 something. So 100 upon 24 roughly. Even if I just made it 100 and I made it made it 24, just pure rounding off would have also led me to a very fine answer. So yeah, 100 upon 24 would be 4.1, 4.2 something. So something like 4.1 or 4.2 into 10 raised to power 5. So into 10 raised to power 5. The real answer is, yeah, so 4.1 something into 10 raised to power 5. Works very fast, very quickly. So even if you don't apply the percentage concept that I'm suggesting, if you just keep rounding it off and find out approximate answers, you won't be too far off ever. Let's take another example of approximation when multiplication as well as division is happening very quickly. So let's try doing it. You have some really big number here. So just deal with the power first and then just apply approximation. The real answer is this much. This is just for extra practice. Of course, this won't appear on the test, but if you can solve this, you can of course solve all the easier ones. Let me do this very quickly for you. You have 3, 6, 9, 12, 15, 18, 19 power here. 19. Now to bring this decimal here, I'll have to travel 1, 2, 3, 4, 5. So minus 5. And then to make this a 5.4, 1, 2, 3, 4, 5, 6, 7. So minus 7, because when this goes up, this becomes negative. And to make this 9.3, further minus 3. So 19 minus 15 is 4. So practically what I have here is 7. Just remove all the smaller parts. 7 into 2.3 upon 5.5 into 9.4. So this is approximately 4. 7 upon 22 is approximately 7 upon 22. I know that's the value of pi. That's 3.14 into 10 raised to power 4. So 3140 is what I want. 3238 is the real value. So very, very close. A mix of all, really, really inhuman. Okay, not very inhuman. However, we were to solve this value. So see, put an 8.23 here. So 10 into 2.9 is 8.41. So this should be roughly a bit less than 2.9. Take it 2.9 for keepsake. Square root 28. 5 square is 25. 6 square is 36. So 25, 36, the difference is 11. 25 and 28, the difference is 3. That's approximately 0.3. So that means this is 5.3. 20, 4 square is 16, 5 square is 25, the difference is 9. The difference here is 4. 4 upon 9 is 0.44, a bit higher than this. We can take it as 0.5. So upon roughly 4.5 is what I have to figure out. This would be roughly 1.2. 1.2 here. 29 into 1.2 is roughly 34.8, 35, something like that. 34.8, 35, something like this. So yeah, 34, 35 is what I was getting. I am close. Of course, I did some real broad approximations and I could get to a value around 34 in a relatively much shorter span than what I would take if I were to actually find the value. All right, the next concept. I would say approximation is a life skill because you can use approximation in all sort of things. So when somebody comes to me with a business idea, okay, this is the idea on my drive back from office to home, I just keep running numbers in my mind backwards, and towards the end of the drive, I can figure out whether it's a profitable idea. Of course, what I'm doing all the time is approximating. So you can use this approximation skill for finding out cubes, cube roots, sine, cosine, tangent, log, exponents, all sort of things. I can explain you that, but this is more out of hobby, and these things do not appear on the standardized exams. They never expect you to find out these out of your head. So yes, it's good fun to just find out approximation. That if you know cube root of, for example, a 12 is to be found out, you know that 2 cube is 8 and 3 cube is 27. The difference is 19, but you have only 4. 4 upon 19 is something like 2.1, 2.2. So the value should be something like 2.22. I'm sorry, this should be 0.22 something. So a bit more than this. So yeah, something cube root of 12 should be something like 2.24, 2.5, 2.5, something like that. And the right answer is 2.28. So yes, you can apply this very technique in finding all sort of stuff. The next concept, using answer choices in geometry questions. This is another very useful shortcut, I would say. So let's take a difficult question. No, I'm sorry, this is not a very difficult question. You can solve it directly also very quickly. But suppose this is a question, you have to find the value of this angle here, and these are your answer choices. One concept that I would explain is, see, if there is one line, You have to go from point A to point B. See, the higher route you take, the longer route you take from A to B, the higher you go, the longer you go, this angle will keep getting smaller, and these angles will keep getting bigger, you know. So see, if I took a shorter route, here this angle is bigger, but relatively these angles are smaller. If I do not make an angle at all, if I just take the straight line, see, this angle is the highest possible angle, 180 degrees. And the vertical angle, these angles have become zero, you know. So remember this small thing, it will help you a lot. So I know it says that DEC is an equilateral triangle. So this has to be 60 degrees. Now come to think of it, from D to C, I am here, this is lying lower. This is a shorter route, so F has to be a bigger number than 60. So these values can just go, it has to be greater than 60. These are the two contenders. And now come to think of it, 80 is such an absurd number. Talking about square, the angles are 90. Talking about equilateral triangle, the angles are 60. Talking about a diagonal here, the angle is 45. So 90, 60, 45, there is no way you can get to an absurd number like 80, you know. So out of these numbers, 75, see, makes some sense, you know. A 75 can be reached at, you know, through some addition, subtraction and all, you know. Remember that triangle, whenever a triangle is involved, a number like 180 is always somewhere around the corner. So look at these numbers, a number like 80 cannot be reached, you know. This has to be also eliminated. The right answer is 75. Of course, practically if you were to solve it, it's an easy question. 45 here, 60 here, and therefore 75 here. But see, the 75 has been reached by these values only, 180 minus 60 minus 45, you know. So in case this doesn't strike, you can always, you know, apply this common sense. You know, when I was taking my tests, I would very often apply these shortcuts before I would actually go about solving the questions, you know, if the options just look completely wayward. Take one more example. This is a square, this is an equilateral triangle. The question is asking this angle. And these are the answer choices. Now what I do is, again, similar stuff. I just eyeball. I would need to make sure that everything is to the scale. Yes, it is a square. And I would just need to make sure that, yes, this is also looking equal. So it is a figure drawn to scale. And then I just eyeball that, yeah, number like 45 is too big. See, entire thing is 60. So 30 would mean half of this. This is definitely not half of this. This is less than half. So 30 can also go. Now see, I have 3 close choices. But once again, the same concept. I'm dealing with a square, so I have 90. I'm dealing with an equilateral triangle, so I have 60. When a triangle is around the corner, something like 180 is always there. So think a number like 10 or 20 is awkward, you know. Whatever happens, whatever number I'm going to get has to be, these are all multiples of 3s. You can add and all, you know, you never divide. So whatever result I'm going to get has to be a multiple of 3. Okay, 10 and 20 are not a multiple of 3. The only value that remains is 15 degrees. That has to be the right answer, you know. Doing it mathematically, of course. This is 60. This is 90. This is 60. So 90 and 60, 150. And these two sides are equal. So these two angles have to be equal. 150 is taken from here. So 30 remain. Each of them have to be 15 each. That's a mathematical way, but yeah, of course, under exam pressure sometimes this may not click. So this is how you reach to the right answer very quickly. Let's take one more example. This is quite a difficult question. You have to find the area of this part, and this is a rectangle. It's given that figure is not drawn to the scale. Even by eyeballing, I can sense that it is not drawn to scale. This is 3 and this is more than double this value. See, this eyeballing and approximation is going to work only when you have the figure drawn to scale. So the first thing that I'm going to do here, if I am to solve it by approximation, is to have a figure drawn to scale. If this much is 3, 4 should be like 30%, 33% bigger than this. So this now looks like a 3 by 4 rectangle. So I first draw this. If I'm drawing it on my scratch paper, I would have proper boxes, and also it would be easier to draw it on paper to the scale. I'm drawing it on screen, so it is just a bit okay, difficult. So I know this is 3, this is 4, so this becomes 5, and EF is 2. So 2 should be like less than half of this, just a bit less than half of this. So something like this. This much should be 2. So now I have a figure which is drawn to scale. You know, I have to find out this value. How do I do it? By approximation. I know the entire rectangle is 12. So this rectangle, this triangle has to be half. Area of triangle ADB, half triangle is 6. And I need to figure out that what percentage is this area out of the entire area. So for this, what I suggest is you just try to break this entire thing into smaller symmetrical things. So I draw something like this. So try to have smaller areas of equal value. So now see this, these two triangles become almost equal. This becomes almost equal, so these two, and this would become almost as equal in area. So I have 1, 2, 3, 4, and roughly 5, a bit more than 5, something like this. This is narrow, so probably this entire thing can be counted as 1. So I have 5 areas of this size, this triangle, this size, and this required shaded part is taking 2 out of roughly 2 out of 5 parts. The entire thing was 6, so 2 out of 5 should be roughly 40% of this. So that is 2.4. That's the right answer. So this was a very difficult question, but yes, this eyeballing may just help, and some of the answer choices by eyeballing you can figure out do not make any sense at all. You know, it has to be a value approximately 40% or so of the entire this triangle. And again, you can look at this. You have a 3 here, you have a 4 here, and of course while finding out the areas you have a 2 here. While finding out the areas, somewhere these numbers are going to be multiplied, you know. And the other choice that makes some sense approximation wise is 2. So from a 3, 4 and 2, by multiplying it's virtually impossible to get to a 2. My result once again has to have a 3 in it somewhere, you know. So this has a 3 in it. If I had a number like 2.2, this would be even closer, but think, for getting a 2.2, the prime number I need is 11. Where do I get 11 out of these 3, 4 and 2s written here? Suppose the number was 2.3 also there. For 2.3, the prime number I need is 23. I would never get a 23 out of these values given here. So even if there were some answer choices closer to 2.4, I know that through these numbers I don't get to the relevant prime number for getting such values, you know. So 2.4 has to be the right answer. Okay, some more. So this is another very difficult question here. It's given that these are 2 circles. These are the centers, and when you join these points, they all become tangents. This is what is given. If you try solving it mathematically, you may be able to solve it, you may not be able to solve it, but by approximation you'll at least be able to make an educated guess. Please remember, I'm not recommending approximation over conventional methods. I am suggesting this as a smart tool for saving time sometimes, and of course for making educated guesses when you are not able to solve the question through the conventional means. So let's look at this. The radius is 10. That means one circle has an area of pi r square, which would be pi into 10 square, 100 pi. The answer choices are these. 100 pi is the area of the entire circle, and come to think of it, how much is this as a part of the entire circle here? Roughly 20% or so. This is 1/5 of a circle, something. So, or maybe even less, 15%, 20%, something like this. So my answer has to be something like 15 pi to, on a higher side, say 25 pi. It's definitely not 25%, less than that. So 20 pi. 15 pi would be roughly 50, and 20 pi would be roughly 70. So my answer has to be between, say, 50 and 70. And now let's look at the answer choices. 50 to 70, 20 can go. 50 pi would be like, this is like 160 plus. This can go. 50 pi minus 100 is like this is around 50, 60. This is in the range. This can stay. 100 pi minus 100, this would be above 200. This can also go. So we have three options eliminated. We are between 50 and 50 pi minus 100. Only two options make some sense. See, the values are very, very close. Both the values are approximately 50. But then come to think of it, this is talking about area, and there is a curve involved. There's a curve involved. It is practically not possible to have an answer free of a pi in it. See, the answer that I have for the entire circle is 100 pi. That's the value of the area of the entire circle. This is a curved thing involved. Whenever a curved thing is involved, there, whether it's area or the perimeter, a pi has to come. So although the values are very similar, very close, I would go with an answer choice that has a pi in it. This is the right answer choice. All right, so with that, we have covered quite a few concepts. There's no end to these techniques. I've tried to cover the ones which are the most helpful. Again, please don't make this the main course of your preparation. This is all only for helping you with that extra edge on the D-Day. Hope this helps. For any queries, write to us. We'll be happy to hear from you. Thanks for watching.